All right, let's look at the midterm exam, problem number 13. All right, so I'm trying to do the part A and part B in kind of one shot. All right, so instead of looking at the cosine and sine, I'm going to look at exponential expression. So for example, we can just look at the e to the I theta. All right. Then we have let's see, it's going to be 3 theta, so e to the I 3 theta plus e to the I 5 theta, and so on. And I guess it's going to go to e to the I 2n minus 1 theta. All right. Then you can see that if you take the real part, you're going to get the cosine. So this is going to be our the real part, and this is going to be imaginary part. Imaginary part. All right. Right, but you notice that this guy happens to be a geometric series, and this is a partial sum of a geometric series. Right, and so it's a geometric series. For example, the leading term, so A in this case is the first guy, so it's going to be e to the I theta, and every time you go to the next term, you multiply by e to the I 2 theta, right? So you multiply e to the I 2 theta, right? Which means that our value is going to be e to the I 2 theta, right? So we know that the partial sum of a geometric series would be a times 1 minus r to the n over and 1 minus r, right? So that is the partial sum. So let's try to do that. Right, so this is going to be equal to, right, e to the I theta, so I put e to the I theta, and then you have 1 minus, and let's see, e to the, actually you have to raise it to the n, so e to the I 2n theta, and over 1 minus r, which is e to the I 2 theta. Alright, so we have that. Then in order to simplify this right hand side, we're going to use the this trick. Right, so I'm going to put the let's see, I'm going to work on try to work on this guy right here. Let's work on this guy, and you can do this similar thing with this guy. Alright, so first, so we start out with 1 minus e to the I 2n theta. Alright, then I'm going to pull out the negative e to the in theta. So factor out negative e to the in theta. Alright, so I'm going to actually work on the second term. So if you pull out the negative e to the in theta from negative e to the I 2n theta, you're going to get e to the in theta. Right, if you take negative e to the in theta from 1, so it's going to be negative e to the negative in theta. Right, then what we're going to do is, since we have the numerator of the definition of sine of n theta, so what we can do is we can just, let's see, we're going to divide through and multiply. So I'm going to divide by, say, 2i, and multiply by 2i there. Alright, then you can see that this guy right here, right, this guy right here is exactly the same thing as sine of n theta, just by definition. So it's a sine of n theta. All right, then so what you get is going to be this. Right, so you have a negative 2I e to the I n theta, and then you have so this part is just a sine of n theta, right? Then so once you can do the top one, so this is the top one, and the bottom one, only difference is just the n is 1 in that case. So by doing the same thing, we can find 1 minus e to the I2 theta is going to be simply negative 2I e to the I theta and sine of theta. Right? So we got that. So all you really have to do is put these guys. So we got this guy and plug it in here, and put this guy and plug it in here. Then simplify it out, and then you take the real part. It's going to look like part A, and take the imaginary part, which is going to look like part B. And you might have to use some of the trig identities, but since the answer is already given, so it's probably easy to find out. All right, that's it. I hope that this will get you guys going.